My dearest little sisters and brothers, it is your AKD sir, your elder brother, in your own channel. It is our channel, the classes which I learned. So we started our journey for the study of science, the stride, the work of science, and I'll be very much with you, and I'll be rather happy if I can accompany you in your journey towards science. So today we will be just studying our journey towards the basic introduction to the science. And if I say science, so the first is science, and the second is matters around us. The science, and thereupon the matters around us. Now, what is science? Science is a systematized and organized knowledge about the natural phenomena around us through the careful experimentation, the observation, and the logical reasoning, and after all, to be truthful, unbiased analysis of the results of that, and that in our terms is called to be science. Rather, science is a quest for the truth finding. So the scientists, in other words, the truth seekers. They are the truth seekers, and those who want to be the walkway of science, they must be prepared themselves to get their answers of the why, what, how, and when. So these are the questions I will suggest to my junior friends to be ready to ask. So far, you want to stride in the way of science. Okay, this is in a nutshell what we say about the science. Now our second thing is the matters. Now what is matters? What is matters? Matters is that, matters is anything that which has got the mass, and that occupies some space. So the matters must have some mass and it will occupy some space. So on the reverse way, you can say that those that have the mass and occupy some space can be called as matters. Okay. Now what is mass? You can note the terms we are using. We have used the science, the matters. Next we have used mass. Okay, occupation, space. These are all the terms that in our due course of journey we will elaborate one after the another. Now what is mass? Mass is it is the amount of substance with which a matter is formed. It is the amount of substance with which a matter is formed. Okay, and a space. A matter must occupy some space. Okay, so the occupants of the space requires the matter to have some volume. Okay, so that is mass and space. Now, while we talk about the matters, natural these terms mass comes. So in this context, I must mention you that there is a law that which we call the law of conservation of mass. And what is that? It says that the total mass of this universe is constant. The total mass of this universe is constant. But nowadays, we know that though it is true, but it is not the whole truth. After the suggestion of that famous formula, E is equal to mc square by the eminent scientist, Sir, Einstein, Albert Einstein, whereupon E is called to be the energy and M is the mass. So the mass and the energy is correlated by this formula. That is, you cannot say that mass and the energy are some separate identities. Rather, we take these two quantities to be a unified one when upon the mass and the energy has got some relation. So nowadays, we say that it is the law of conservation of energy and mass. It is the law of conservation of energy and mass. That is summed together, the energy and the mass of this universe is constant. And there comes another law of conservation, we call it the conservation of charges. That is, the total amount of the charge of this universe is constant. Okay, so these are the sum of the basic rules, we discuss about. Now, while the matter has some mass, so we'll be interested to know that what does the matter is composed of. Here lies the difference of the different, the streams of science. With the rapid advancement of science, with the rapid advancement of science, so we had to classify the entire concept of science into some different streams, like the physics, the chemistry, the biology, and mathematics. Already I have taken a class of mathematics whereupon I have said that mathematics is the basic language of science. If you are to, walk your journey with the science, then you must have the knowledge of mathematics. So the matter in the language of the man of physics will be that, the matters are the substances that which is conformed with some tiny particles. Some tiny particles we called, some tiny particles, they call it the particles. But a chemist will say that you use the molecules, you use the atoms, and that on. Now, what is a matter around us? Now you see, if you look upon around you, you can see all lots of things that is there in your visual world. Like, it is the bricks, it is the trees, it is the water bodies, and what not. Only the thing is that the matter must have some mass and some volume. And the other term which we must include in this context, that they are, they will respond to your sensory organs. That is, you can see, you can touch, you can smell, you can have a taste on your tasty buds of the tongue. So with this thing, you can have. So either they are observable or that. You cannot see the ear. We are dipped into the ear, you know it, but we cannot see ear. But if you wave your hand through the ear, you can feel that you are feeling something, some sensation that is having a sensation on your skin. We say, because it is giving some sensation to my sensory organs, that is skin. So that's it. But if I say you passion, love, affection, thoughts, These are not the matters here. These are not the matters. Okay. Now talking about the matters around us, we have seen that everything that we see around us, we can touch, we can see, we can have the smell of it, we can have the taste of it. Okay, these are matters. Now, if a humble piece of chalk is given to a man of physics and a man of chemistry, what will be the difference in the observation? Though they both represent the man with the science. So where a piece of chalk is given to a man of physics, he will be taking it as a substance or a matter, and he will be taking his measuring instruments, he will be measuring its thickness, its length, and so on and so forth. Now if you ask him to grind it to powder, still he will be saying, yeah, it's a matter of chalk, Only the fact is that that lump of the chalk piece has been grounded down to the powders. But if the same thing is given to a chemist, what he will be doing? He knows all these things, He knows that this chalk is nothing but the calcium carbonate. But a chemist will not be stopping there. He will be taking some amount of oil of vitriol, we call it the sulfuric acid. He will be dipping the chalk into it, and thereupon he will be saying that some effervescence of a gas is coming out, we call it carbon dioxide, and ultimately that will be coming down to the calcium sulfate. Now he will be filtering it out, he will be washing it once again, and then he will be heating once again to give you a substance that is the new one, we call it the plaster of Paris, 2CH dot H2O. So this is the difference between the looking through the matter between the physics, a man of physics and a man of chemistry. But if this same chalk is given to a biologist, he will be first seeing, oh, this is a piece of chalk, it doesn't eat, it doesn't, it doesn't reproduce, it doesn't, have the enlargement, it does not, nourish, it's a dead one. So to a biologist, a chalk has got no life, okay, the rest is the different. So this is where the science is being differentiated, okay. But the science is such expanding, the field of science is expanding in such a way that ultimately we are compounding these all subjects into, or we're trying to this thing, Nowadays, only a man of chemistry, only a man of physics, only a biologist, we do not say it. We have carved up the subject like biophysics, okay, like biochemistry, okay, the mature physics and also all this, But my dear friends, the scope of science is so wide, so spread, that those who are opting to have your journey, opting to strive to the path of journey for the rest of your life, you are welcome. You can do it. Okay? This will be giving the enormous pleasure, immense pleasure. I give you the guarantee, Only the thing is that you want to raise your mind in that way that you are going to take the pain of striding your journey to the path of science. Okay? Now, my dear, already we have discussed the matter, and with the outlook of a physicist, the outlook of a man of physics, we say that the matter is made up of some particles. And the particles are very minute, very tiny, very, very tiny. You can add on the adjectives. But does it mean anything, in the language of science? Very tiny. What is that, sir? This is practically invisible in the naked eye. With our naked eye, we cannot see the particles, So to give you some idea about this tininess, we have got some scale. Now my dear friends, already you have the idea of a centimeter. That is very much there in your geometry box of scale, and the length of that which is called to be a centimeter you are acquainted with. And when you go to the the cloth shop or dress material shop, you see there is a stick, they call it a meter rod. That meter rod is nothing but the 100 centimeter of length. Okay, so with this your practical idea of a length of 1 centimeter or be it 1 meter, let us discuss what this very tiny etc. that we are talking about the particle size, let us discuss it. So what a tininess. Already I have said this is invisible to the naked eye. Now let us discuss how tiny are they. Already you have learned that a deci means 10 to the power minus 1. That is 1 by 10 part of a meter. A centimeter means 1 by 100 part of a meter. Milli means 1 by 1000 part of a meter. Okay. Now all this we abbreviate with the small letters D, C, M. Then comes the micro, 10 to the power minus 6. 10 to the power minus 6 is 10 lakhs. Okay. That is 10 lakh part of a meter. 10 to the power minus 9, we call it nano. 10 to the power minus 12, we call it pico. Femto, 10 to the power minus 15, femto, symbolized as, denoted as small f, and atto, 10 to the power minus 18, okay, meter. This is called to be the atto, okay. Now let us have some practical idea how in between that there is one unit, a practical unit we call it. It is continuously used so far as the chemistry is concerned, we call it 1 angstrom. It is a degree sign over capital A. It is called to be 1 angstrom, A-N-G-S-T-O-R-M. 1 angstrom, that which is 10 to the power minus 8 centimeter, or it is 10 to the power minus 10 meter. Okay, 10 to the power meter. Already you are getting some idea how small the size it can be. Now let us go to some practical example. You may or may not be knowing this terms, the proton. Now the radius of a proton happens to be 10 to the power minus 15 meter. It was ending at 10 to the power minus 15 femto minus 15. Size of the atomic nucleus, we are calling this to be the size of, and when we mention the radius, we have the supposition that it is a spherical object. Now size of the atomic nucleus is 10 to the power minus 14 meter. Size of the hydrogen atom, the most simplest atom in the periodic table, will be discussing this at a later on time. The size of the hydrogen atom, it is 10 to the power minus 10 meter, and that which happens to be 1 angstrom. Now size of a typical virus, it is 10 to the power minus 6 meter. Size of a red blood corpuscle, it is 10 to the power minus 5 meter. Now talking about your humble paper that you daily use in your exercise book for your practice session, that is a paper. Thickness of a paper, it is 10 to the power minus 4 meter. What does it mean? It means that 10 to the power 4 means 10,000 pieces of paper. If you aggregate it, sum it up, this is going to measure 1 meter. So we have got some idea about the tininess of the particles. Now, if we want to discuss the physical characteristics of the particles, if we want to discuss the physical characteristics of the particles, such tiny they are, but still their aggregate will be constituting the matter. The matters will be having a particular shape and a size. Okay, and the matter is constituted by the particles. Now, how are the particles, How are the particles that is within the matter, that which is aggregated to form the matter, how are they? Are they good boys and girls like you? No. They are always in motion. They are always in motion. Now, another term, motion, it is once again a very much deceptive term, It is relative one. We will be discussing this motion at a later point of time. Motion. So, these particles are not good behaving bodies. They are always in motion. They are always in motion. They are in ceaseless, continuous motion within the matter. Now, dear, if the particles are in motion, so there must be some amount of energy. There is definitely some amount of energy that which is causing the particles to move. There is motion. If there is motion, there is kinetic energy. So, someone may ask, so what is kinetic energy? Okay. So, we will be discussing that all. A kinetic energy is a form of energy, that which is giving the particles the required energy to move. Now, if they move, then we must know about the type of the motion. To discuss it, we will be having a length of discussion for when we will be discussing the physics. Now, but for the time being, let us discuss that what is motion. Motion are of some three fundamental kinds. One is the translatory motion. It is a translatory motion. It's a translatory motion. And another is a circular motion. Motion in a circle, And the third is a to and fro motion. Okay, it's a to and fro motion. We call it vibration or oscillation, whatsoever. And a motion can be the aggregate or a combination of all these three kinds of motions. But ultimately, we know that the particles in a substance or a matter is always under motion. Yes? But when the particles are such closely bound that the particles are not given some access, are not given some access to go apart widely, they are bonded together by some force, it's a great force, we call it intermolecular forces. We call it the intermolecular forces. That intermolecular force binds these particles together. Okay? Now, if the intermolecular force is such that this matter is getting some definite shape and size and a definite volume which will usually not change under the normal condition. So, we call this type of substances to be the solid. Okay. But if the particles have some intermolecular space more than that of the solid particle, that is, some access is given to the constituent particles of the matter to move such that their space between the particles, that is the intermolecular space of the particles, is somewhat widened, then this type of matter is called to be the liquid. Now, what the liquid is? The liquid has got a definite volume, but it has lost the shape and size. So, the liquid cannot be held unto their own like the solid, You can place a piece of pebble or a stone or a piece of glass or your book, whatsoever the solid substances, out of its own it can stand. But you cannot put a liquid out of its own. when you take some water, you take the water into a glass, and that amount of the liquid water takes the shape of your glass, but it has got a volume. You have taken some 250 ml of water. That 250 ml of water, when it is put into a glass, it will be taking the shape of the glass. If it is poured into a cup, it will be taking the shape of the cup, and so on. Okay, so it has got no shape and size out of its own, but the thing is that its volume is a constant one. But what about the gas? The gas is a kind of a, like the, like the, loitering boys and girls in your pada. They have got not their prefixed periphery of loitering. They can go everywhere they like. Okay. But here also, there will be three things to be considered. The volume, and we'll be taking another two quantities as to give them the state. One is the pressure and the temperature. So the temperature has got a good role to play in the case of the gas, So under a definite temperature and pressure, a gaseous body of some certain amount of mass will have a definite pressure. Now, what is the pressure of a gas? Like the liquid, the gas has to be held onto a container, and it will be taking the shape of the container in which it is kept. But what is the pressure then? What is the pressure then, my dear friends? I have already discussed that the particles of the matter, here it is gas, they are in continuous motion, thus colliding amongst themselves, and as well they are colliding with the walls of the container. Okay, this collision will be creating some amount of force exerted on the wall of the container, and that the pressure per, the force exerted per unit area is called to be the pressure. So the gas molecules will be exerting the pressure on the wall of the container. We will be discussing when we will be discussing the gaseous bodies. But roughly then we have categorized the matter into some three broader classes. One is called to be the solid, the other to be the liquid, and the third is the gaseous body. They have got their own properties, they have got their own characteristics. And apart from that, in our modern times, we know that there is some another two state of a matter. What are that? They are the plasma state, Plasma, plasma state, and the other is we call the Bose-Einstein condensate. This Einstein is also, Albert Einstein, and Bose is our very own Indian scientist, Dr. Satyan. It is not doctor, it is Satyan, national professor. We are, we should be ashamed that we didn't confer that gentleman even with a PhD degree. Anyway, that's a separate matter. So is Satyendranath Bose. In 1920, he worked out some mathematical formula out of this conception. Why mathematical, already you are knowing that this type of sizes, oh my God, oh my good God, what a size we cannot conceive, 10 to the power minus 15. Oh my good Lord, what a size. Okay, and I am not perplexing you, my dear friends. When I say the mass of an electron, it will be 9.1 into 10 to the power minus 31 kg. My good Lord, 10 to the power minus 31, does it mean anything? Does it mean anything? You will be simply, our, headache will start. Just to conceive it, 1 gram, just a lentil seed. Approximately, this is a lentil seed. In Bengali, we call it musur dal. Ekta musur daler dana, a simple grain of a lentil seed. If it is approximated to be 1 gram, then you have to put it out to what an extent? 10 to the power minus 28 times. 10 to the power minus 7 is a part of a crore. So it's a crore, a crore, a crore, and a crore part of a lentil seed. My good Lord. So this is the thing, So Why it is mathematics? The mathematics needed because you want to take a mathematical model to have the idea of that. And that mathematical model, our very own Dr. Bose, it's not doctor definitely. I beg your pardon. He was a national professor, Satyendranath Bose. He worked it on mathematically. He conceived it on a mathematical model. And Einstein, the greatest scientist of the last millennium, he got the importance of that, and finally they could conceive of a state of matter that we call the Bose-Einstein condensate. Okay? Now, my dear friends, permit me to end my class, that is our discussion for this day. And before I conclude, once again, I will be requesting your favor that those who like my class, those who are permitting me to accompany your journey towards science, are welcome to like, to subscribe, and when you subscribe, give a ping to the bell icon so that you can have the notification when I upload some new video, or you can comment, or you can like. And if you are commenting, I assure you that I will attend every comment to be addressed. If you have some doubt, don't hesitate to have your comments placed in your comment box. Your comment is most valuable to me, my dear friend. Okay? Thanking you all.